Meet K2-18b, a world unlike anything in our solar system, and yet, in one crucial way, a little like Earth. It could harbour life. For decades, we imagined life on planets like our own, where the interactions of water, energy, and the chemistry of rock and mineral come together. But the planets we're finding beyond our solar system tell a different story. The most common type isn't Earth-like at all. It's something else entirely. Known as Sub-Neptunes, these are large worlds wrapped in thick atmospheres and once dismissed as too extreme to support life. And yet among them a new category is emerging: Hycean planets, ocean-covered, hydrogen-rich and shaped by conditions unlike anything we've ever known. I'm the Cosmic Skipper, and in this video we'll explore what makes these mysterious planets so different, why they matter, and whether one of them, K2-18b, might be hinting at the presence of life. In recent decades, our telescopes have grown more sensitive, like the Kepler telescope that has helped discover thousands of exoplanets. One type has appeared more than any other: Sub-Neptunes, planets larger than Earth but smaller than Neptune. They're not quite rocky, not fully gaseous, there's something in between, and strangely we don't have a single example in our solar system. Thought to be composed of a rocky or icy core, these planets are wrapped in a thick atmosphere of hydrogen and helium. Many are shrouded in clouds, their interiors hidden from view. For a long time they were considered unlikely places for life. Their atmospheres were thought to be too thick, their temperatures too unstable, their chemistry too alien. But that view is beginning to change as our telescopes advance, and one in particular has caught scientists' attention: K2-18b. In 2019, Hubble detected water vapour in the atmosphere of this planet, the first such detection in a planet of its kind, orbiting within its habitable zone. A discovery that has changed the way scientists thought about these large hazy planets, suggesting that despite their alien nature, they might hold some of the conditions needed for life. It raised a new possibility that some of these distant hydrogen-rich worlds could support oceans, perhaps even life. And in 2021, this type of sub-Neptune was given a name: Hycean worlds. With a hydrogen atmosphere and a deep ocean below, the term Hycean blends hydrogen and ocean in one phrase. They are theoretical, but it's a compelling idea. Proposed in 2021, they offer a new lens through which sub-Neptunes are viewed, revealing a new realm of possibility in the search for life. If the pressure and temperature are just right, a planet like this could host a vast ocean beneath its thick atmosphere, not resting on rock, but layered over exotic ices or supercritical fluids deep below. These oceans wouldn't resemble anything on Earth. They might be hot, dark and pressurized, sealed off from much of their star's light, isolated by dense gas. With no land masses to break their motion, waves could circle the globe endlessly beneath hydrogen-rich skies. Shaped by atmospheric conditions we can't yet imagine, Hycean worlds are truly alien seascapes. And yet, for all their strangeness, one thing remains familiar: water, one of the most important ingredients for life. What makes Hycean planets especially intriguing is they could exist over a much wider range of distances from their stars than Earth-like planets can. The greenhouse effect of hydrogen could keep them warm, even far from their star's traditional habitable zone. And they're not just intriguing, they're accessible. Hycean worlds are larger and often brighter than Earth-like planets, which makes them easier to detect and study from afar. That's part of what makes them so promising. Not only might they be habitable, we might actually be able to find out. K2-18b is the best known Hycean planet we've discovered to date. It was first detected in 2015, when astronomers noticed a subtle dip in the light of a red dwarf star 124 light-years away. That dip repeated every 33 days, signalling the presence of a planet. It orbits within the habitable zone of its star, where temperatures might allow for liquid water. It's about 2.5 times the size of Earth and nearly 9 times as massive. In 2019, interest grew when Hubble detected water vapour in its atmosphere. Then in 2025, the James Webb Space Telescope took a closer look, watching as K2-18b passed in front of its star. As starlight filtered through the planet's atmosphere, some wavelengths were absorbed, others transmitted, leaving behind a chemical fingerprint. This technique, known as transmission spectroscopy, found signs of methane and carbon dioxide, gases that can be linked to biological or geological processes. And it hinted at something even more remarkable: the possible presence of dimethyl sulfide, or DMS, a molecule that on Earth is known to be produced only by life, most notably by marine organisms like phytoplankton. But the detection is still tentative. There's still a small chance, about 1 in 370, that the signal isn't real. In most fields, scientists wait until the chance drops to less than 1 in 3.5 million before calling it a discovery, and even if the signal holds up, we're still not sure what caused it. Interpreting it depends on the models we use, from atmospheric composition to temperature and cloud cover. Scientists test many scenarios to see which one best reproduces the data we observe, building a range of possibilities rather than settling on a single answer. One of these models includes DMS, but that doesn't confirm it's there. All of this means we don't have evidence for life, not yet, but what we do have is something worth paying attention to, because in the strange skies of K2-18b, the question of whether we're alone just got harder to ignore. And maybe, just maybe, the answer lies hidden in the clouds of a Hycean sky.